The ones who were making noise who weren't ready, though. All right, let's do this. So today's our standard examples lecture. It's the last day of content for a block of homework. We're in these 3-week blocks. As usual, consistent throughout these things. Last one's all examples. So I got to finish up the WebRTC code. I want to go through the front-end code and just wrap that conversation up. And then move on to some examples. As always, I have some pre-canned examples ready for you right here if nobody has suggestions. But I would prefer to go over whatever's giving y'all trouble. And judging by the empty seats, I think a lot of y'all are having trouble. Or maybe you're the ones who are not having trouble and everybody else skipped the class to work on the homework. But it is what it is. Homework 3 is, which I'll never understand this. Homework 3 is tough. Like I'm sure that's what most of you are stressing about right now. And that's probably why a lot of students aren't here today, because they're working on it. But this is specifically the lecture where I help you finish homework 3. Like, why would you not come to this one? I don't understand that. I'm refreshing the page, and it's taking way too long. But if you refresh the page... Oh my God, where am I? The long-awaited project part 4 is up. So if your team is ready to start thinking about project part 4, there it is. It's ready. I'm happy that it's out. I'm excited about project part 4 as well. Or maybe I'm the only one excited. But we have some new content. For those of you who do care about this kind of thing, I do. I might be the only one who cares about this also. But I did change the order of the schedule a little bit. So just a heads up, the order of some of these topics during the homework 4 content was shuffled around a little bit just to make sure it's in the right order for the project part 4. So I get all the content out early. And then these two things have nothing to do with homework 4 or project part 4. So I want to make sure those two things were last. So those are kind of just like bonus topics that I'm going to talk about. It's going to be fun in lecture, but you're not held accountable for these two at all. But the other ones you are. Okay. Ooh, this is going to be a really stupid question. Whenever somebody prefaces, this will be a stupid question, it never is. It's always a really good question. But can we go over serving file? Watch this be the exception. Hold on. we go over saving files to the server again. It's been giving me more trouble than I expected. Yeah, absolutely. See, this is a great question. Saving files to the server. I have to think about how to do that in a demo. Don't let me forget to come back to it. Can you go over buffering larger images and how to use receive to keep reading bytes into the buffer? Yeah, I like this. I like getting suggestions. Can we go over reading extra bytes on WebSocket buffering? Yeah, I can do all these things. Let me see what Let me just get into it because we got a lot of good suggestions here and I'd like to get to them all. Oh, and I didn't do I didn't change PyCharm to big mode. Hold on, give me 1 second. Okay, let's wrap up the WebRTC stuff pretty quick since y'all are stressing over the learning objectives, I'm sure, not necessarily the WebRTC stuff. But we have an offer. If we get a message of type offer, that means the other peer is establishing the connection. A few things we have to do: set a remote description to the offer. The offer has all kinds of information in it. So we're going to take the offer part of this message. Remember, a message is a JSON object that's going to have the message type and the offer itself. So we're going to get the offer itself that was generated by the other client, jam it into this session descriptor constructor, set it as our remote description, and then the browser does everything else that we need with that offer. And then we're going to create an answer, use another promise. When this answer is created, it's going to call our function that takes an answer as a parameter. And then we're going to set our local description, as opposed to our remote description, as our answer. So whether we create the offer or the answer, it's really the same information. It's just a question of whose first sending that information to the other client and then who's responding to that. But it's the same information in an offer or an answer. So we're going to set that as our local description and then zip it over the socket so it goes over to the other client. When we receive an answer, all we need to do is set it as our remote description. We don't have to send anything because if we're getting an answer, that means we already sent our information in an offer. That client already ran this code and sent us the answer. So now we're going to handle the answer. And whenever we get a candidate, we're going to add that candidate to our connection. And that's it. The browser does everything else. We just need to get this information from one browser to the other. So we're really, even our JavaScript code here on the front end and our server code, the signaling server, it's all just passing messages between one browser and the other browser. That's all I want to say. Oh, and I didn't mention this, but when you click that button, the Start Video Chat, it's going to call Connect WebRTC. It's going to create an offer, and then zip that offer over the WebSocket and set its local description, which sets everything off in motion. Everything else is handled after that one button press. The users don't have to take any further actions. It's all code after that. Okay, so we wrap that up. Sounds like buffering is a big thing that y'all want to know about. And saving files. Oh, the extra bytes on the sockets. Okay. I think I can quickly go over this one thing I have prepared. I might not do, since we do actually have some suggestions here that are giving y'all trouble, I'll probably skip parsing the WebSocket frames, but I'll go through it very briefly just so we can actually get it out there. Okay, let me run my server. Let me kill my server so it'll run. Go to my page. Let's start my video chat. Refresh, start my video chat. Start video chat. I'm going to close this one and refresh this one so we don't have that annoying echo the whole time. And just take a look at the WebRTC messages real quick. We have a good number of WebSocket frames that are sent. And we can see all the bytes. I like to print out the bytes in the same format that we have in the spec. That I get the fin bit of 1, reserve bits of 0, opcode of 0, 0, 0, 1, 1 for the masking bit, a 126 for my 7-bit payload length. That means my payload length is going to be the next 2 bytes. So my payload length is these 2 bytes. I won't bother decoding this. That's one thing I would have done by default is decode this in binary, go to binary to decimal calculator, and figure out what this number is. And it's 5688. That's what it's going to be. In those 2 bytes, if we treat those 2 bytes as a single payload, these 4 bytes are going to be the mask, the masking key, and then this byte is masked with this byte is masked with this byte. And I will do 1 just because this one ended up pretty easy. 0, 1, 1, 1, 1, 0, 1, 1. If we go to our ASCII chart, hopefully we can find one in binary real quick. The internet kills me. That's extra delay. Destroy. No, I don't want to save it. No, I don't want to save it. Okay. So it's 1, 1, 1, 0, 1, 1, which is our open brace. Is exactly what we expect. So when we demask that first byte, we should get the ASCII representation of an open brace because we know this is a JSON string that's being sent to us. So when we demask it, we'll be able to decode those bytes and get the bytes that we want. But it has to be XORed with this which is 0, 1, 1, 1, 1, 1, 0, 1, 1. That's exactly what we get in the ASCII chart. So that's what I mean by XORing. It's a bitwise XOR operation to be able to demask these bytes. If you try to do anything with these bytes without demasking them, you're going to get nothing but errors because it's effectively random bytes at that time, random bits and random bytes. Then this byte's masked with this one, etc. And we can kind of see all these bytes in the first two columns are going to start with 0. This is all just ASCII text. Every ASCII character starts with 0. Because our masks here start with 0, those are going to be zeros, but our masks here start with 1 in the third byte. So everything in this column is going to start with a 1 because that 1's going to get demasked down to a 0 when it's decoded into ASCII. The fourth column, that's all zeros because they're masked with a 0 in the most significant bit. So everything's making sense the way we expect it to. And then I'm truncating this, so I'm not showing all the bytes because it was a lot of scrolling. And then when this is decoded, so after I decode it, this is what is actually received. Open brace is the first character. That's what we expect. This is going to send, I'm going to search for WebRTC here. Oh. I'm going to search for this whole string. And I can see I got 8 messages sent to establish this one connection. I have an offer. That's the first one. Everything makes sense. The second one is going to be a candidate. So one client is sending a candidate to the other one. The next is another candidate. The next is another candidate. The next is another candidate. The next is an answer. And then a candidate, and it looks like that's it. So we got an offer, an answer, and 6 candidates sent back and forth. This is why it's critical that your WebSockets can handle frames that are sent back to back. Because I click one button, and all these messages just get zipped around the WebSocket frame, all pretty much back to back. And I refreshed it. Actually, let me do it. Nah, I don't want to. You all saw it in the console here. But we can look at the WebSocket messages being sent back and forth, and we'll see all those 8 messages being sent and received. And those all happen like that. It's all back to back. So when you're buffering your WebSocket code, if you're not careful, you are going to read part of that next message, which is one of the questions, right? So I can spend some more time talking about this part of it. Can you go over reading extra bytes on WebSocket buffering? Yeah, and I'll talk about it more theoretically and then try to make parallels to the code. I can't open my code or else you know what'll happen. But everyone takes pictures of it and stuff like that. But your first message, I'll use WebRTC as an example, but this is where you should cut and paste your chat messages. So a chat message is being sent like 5 to 10 times. I would go crazy with it. Don't just do 2, because I've seen many cases where 2 works fine, but once you get to like 3 or 4, it starts exposing your bug. But you can have the bug and still work fine with 2 chat messages. So I would do like 10, 20, 100, do a whole bunch. Write a loop and loop like 100 times, then make sure you get all those messages without breaking. But I'll use WebRTC as an example, just because I have it on the screen right here. Your first message, your first offer, this is the first message you're going to get using WebRTC. Somebody's going to send you an offer. Takes a while just to scroll through it. 5688 bytes for the offer. The offer is going to hit your buffering code. This is a large message. That means the answer is also going to hit your buffering code. So both of these messages have to be buffered. You're not going to read them all in one go, which means you're almost certain to have the next message, that first candidate, is going to be sitting on your TCP socket ready to be read while you're still buffering this code. Everything's like millisecond precision here, and there's going to be enough delay in your buffering that's almost certain to happen. So when you're reading this one, you're going to say, read from the socket. You're going to parse your payload length. You're going to find out your payload length is 5888. You're going to check how many bytes you've read after the headers. So for this case, your headers are 1, 2, 3, 4, 5, 6, 7, 8 bytes. You have 8 bytes of headers. Getting the right number of bytes for your headers is crucial. You already parsed all your headers, so at this point you definitely know how many bytes there are in your headers. There's either 6 if you have a 7-bit payload length, 8 in this case where we have a 2-byte payload length, or I have to do math, 14. 14 if you have the 8-byte payload length. So if this is all ones on this byte, meaning a 127 for your 7-bit payload length, then the next 8 bytes are going to be your payload length. The next 4 bytes after that will be your masking key, and then this will be your first byte of payload. Payload length only counts the number of bytes in the payload. It does not count the header bytes. So when you're reading, make sure you get rid of, in this example, get rid of your 8 bytes for your header. I don't mean get rid of, but you should have ideally some data structure. The way I would code this, the way I did code this, is you have some data structure, some byte array, which is the data structure that receive returns. Some byte array where you're accumulating all of the bytes of only the payload. So on the first read, you're going to parse your headers and then take everything after the headers. So this should be the byte at index 0. Put everything after the headers in a separate data structure, in a byte array, where you're going to handle your buffering code. Then I'm going to buffer. I'm going to call receive, if I have to buffer. I'm going to call receive while the length of that byte array is less than my payload length. Less than, not equal to. Or well, it's not, don't say well, not equal to, less than, strictly less than, or not greater than or equal if you want to reverse it. But make sure you're buffering as long as the size of this byte array is less than your payload length. And as long as that's less than your payload length, read from your TCP socket using receive, and whatever you received, append it to that byte array, which Python makes this easy enough. You just use the plus sign to slam 2 byte arrays together. That's one of the reasons why we use Python. Just makes so many things so much easier. Combining 2 byte arrays in other languages can get trickier. Python, you just use plus. It's super easy to concatenate 2 arrays. Keep doing that until the size of that byte array is greater than or equal to your payload length. So the length of that, len of that byte array, less than the payload length that you read from your headers. Keep buffering. Keep reading from the socket and appending to that byte array. When you get to the end of that, when your buffering loop breaks, when the condition is false, meaning your payload is greater than or equal to your payload length, you have 2 situations here. It's either equal to, in which case it's an easy day. You got a message, you got an entire frame, you have your message, you're going to demask it, handle that message however you want to handle it, however you're supposed to handle it, and then go back to the top of your loop. You would let your code follow out to the end of that loop and go back to the top of your well true and get ready for the next stack frame, or I always say that, the next WebSocket frame. All right, everyone following? The second situation is that your payload is greater than your payload length. And this is the one we need to handle right here. This is the extra bytes situation. We have extra bytes that's longer than our payload length. If that's the situation, we want to take this array containing our whole payload and take the first payload length number of bytes from the payload, and that's our actual payload for that WebSocket frame. We have these extra bytes at the end. Those extra bytes are going to be the next WebSocket frame. It's going to contain at least the headers of the next WebSocket frame, in all likelihood. The headers, at least, of the next WebSocket frame. You can assume that for this course, if that's the bug you hit during testing, the TAs happen to hit that, I'll give you the credit back for sure. But you can assume that has, in this course, at least the headers of the next WebSocket frame. You're going to take those bytes and set them aside. So you're going to have some other variable that ideally has scope outside of your well true loop. If we're thinking of how to code this, you'd have scope outside your well true loop that'll be initialized to an empty array, an empty byte array. And then you're going to set those bytes aside in that variable, go through and process the current frame, and then when you hit the top of your while true, you're going to have some conditional that says, if that byte array is not empty, use that byte array as the start of my WebSocket frame parsing. So instead of getting to the top of your loop and going right to the TCP socket and trying to read bytes, you're going to go to those bytes that you set aside. So you'll say, like, if that array is empty, read from the TCP socket, else this is the start of my next frame, and you can start parsing headers. Or probably just if that's empty, read from the socket with no else, actually, now that I'm thinking it through. With no else, and then regardless, whether you got the bytes, whether you have the bytes that you set aside from the last read, from the last buffering, or if you've just read from the socket directly, doesn't matter, you're going to start parsing headers, no matter what situation you're in. Then set up that way, even if you read from the socket once and there's like 10 really small frames that you read and you got 10 frames, that code should still be able to handle that, because you're just going to keep putting the extra bytes in that temporary variable and keep doing that until you processed all the messages. Does that make sense? That's the two cases: buffering WebSocket frames when the WebSocket frames are large, and when you have extra bytes after buffering a WebSocket frame. Or even if it's not buffering, even if it's the first read from the TCP socket, that first read might have multiple frames. Yep.
If you have a content link, or in this case a payload link, that's less than like 2048,
If you had a payload length less than 2048, so you have a frame that you're going to read all in one go, no buffering, then what was the question?
Wouldn't we just be able to read payload length and bytes if we knew the payload length?
Maybe. I see this in student code all the time. If it works for you, go for it. I think it might. I mean, I've seen it work for students. I wouldn't personally, but if it works for you, it works for you. So the question is, whether I'm buffering or not, why don't I go to receive, instead of just receiving up to 2K, why don't I just say receive up to payload length number of bytes? So I'm buffering. I see a lot of y'all do this. I might as well just put it out in the air. Buffering, and the bytes remaining to be read is greater than 2K, read 2K. And then for that last one, having some conditional, if the remaining bytes that I'm expecting is less than 2K, receive just that many bytes off the TCP socket. If that works for you, if it does, if you are doing that, make sure you're doing it in a robust way. It's possible that all the remaining bytes aren't ready yet. So just making sure you're careful with that. I think you would get away with it, at least in the context of this course, but that is an option if that's the one you want to take. It doesn't handle the situation where the first receive from the socket, bless you, contains multiple messages, but I've seen the solution for that going receive 2 bytes. Check my payload, 7-bit payload length. Depending on what that says, receive 0, 2, or 8 bytes. Then receive 4 bytes, and then receive payload length, do the buffering with the math. If you want to do it that way and it works for you, I feel like it's prone to errors, but I have seen a lot of students get away with it, so maybe I'm just being paranoid about it. If it works for you, go for it. I wouldn't recommend it, though. Which means if you don't get credit and that's what's causing the bug, don't ask me for a regrade. But if it does work for you, you're going to get the points. But it's got to work. Okay. So that was extra bytes on the WebSocket. We got to talk about saving files again, buffering HTTP. How large of image should we be testing our buffer with? I don't have a strict answer for this, at least in the megabyte range, though. If your code is working, we should be able to upload a gigabyte file, and it should be fine. We're not going to, just because the TAs don't want to sit there that long waiting for a gigabyte file to upload for every assignment they're grading. But at the very least, megabyte. If you're not testing with megabytes, you're testing too small. I would go like 10 megabytes if I was doing the homework to submit, just to make sure that everything's working. Because your code should be the same for 10K or 10 megabytes. Your code should be the same, and it should work in both situations the same way. If there's a bug, if I see inconsistent behavior with messages over 65,000, for example, sometimes it's sent fine, sometimes it can be sent, but other times, did we already cover the security for LO1? Okay, LO1 security is one of the things I had prepped, so I'm glad that was asked, so I can actually do that thing that I planned. The large messages, this just was brought to my attention like 28 minutes ago. Oh, I closed the server, so that would just hang there. Okay. Having my webcam light on was driving me nuts. The 65,000 error. So it was brought to my attention just before lecture. I didn't know this was even a thing, so I'm glad we thought about it. This semester, I removed you have to handle a fin bit of 0 criteria. And apparently Chrome sometimes does split messages into multiple frames, even when they're less than 131,000 bytes. And it looks like when you send one large message, it's fine. And then when you send a second one, Chrome splits it into multiple frames. I'm sure it has some crazy algorithm to decide whether it's going to split a message into multiple frames or not. You don't have to handle that situation. It's not a requirement this semester. I didn't go over it in the slides. I didn't talk about it. It's not in the homework doc. You don't have to handle that situation. So if you're seeing that behavior, it looks like it's only in Chrome. If you're seeing that behavior and you verify that it's because the fin bit is 0 on a frame, you don't have to handle that. You can ignore that. I'm going to talk to the TAs about it. We're going to dig up some more information, figure out exactly what situations cause it, make sure we're not running into that in grading. That's not something you're held accountable for. So if that's the exact situation, a fin bit of 0, you do not have to handle that one. If it's the situation where you send multiple frames, say you're using Firefox, or for whatever reason it's not a fin bit of 0 and you're seeing issues, that's usually the buffering code, the thing that we just talked about where you're reading part of the next frame in your buffering and then throwing those bytes away, which contain the headers. And then you're halfway through, or not halfway, but partway through the payload, and you're trying to interpret that data as opcodes and payload lengths and stuff, masking keys and mask bytes. That's when things go horribly, horribly wrong. So if it's not the fin bit of 0 issue, that's where I would look first for your bug. I saw a question. Yep.
So like working with the messages over 65,000 characters or whatnot, does that apply for like the simultaneous messages? So like if you're sending if you're editing the JavaScript to send the message twice, so does that apply as well? Sending multiple messages back to back should be handled with the over 65K unless it's a fin bit of 0. That's something we'll watch for in grading. So it sounds like we'll have to use a lot of Firefox in grading. Because Firefox, I have not seen yet, I'm not saying it doesn't, but I have not seen yet Firefox split a message into multiple frames. But Chrome likes to. I thought Chrome only did it with messages over 131,000, but I have new evidence presented to me half an hour ago that I have to look into. Okay, I stopped the server, but I actually want the server running. I think I can do this one pretty quickly. So I got a lot of questions about this, and I still get questions about this. The security for LO1, this one I'm prepared to go through, so let's do this one quickly. So if I go to the browser, the concern is let me type here so you can actually see what I'm doing.
We have a path that's going to read an arbitrary variable, like basically a parameter that the user is going to give us. Treat that as a file name, open that file, and send the bytes of that file to the user. And hopefully somebody's doing something like this: public image flamingo.jpg. And then that path should return the flamingo. So let's go to this path. We get a flamingo. Like when things work. And some nefarious user is going to start navigating your directory structure. And as a proof of example, a proof of concept, I'll try to get the server code. To get the backend code, this is something that should never be sent to the client, but I should be able to make a request. My server right now is unprotected. I removed the line that says extract the file name, and then I had a line that said replace any slashes with empty string. That's all I expect y'all to do. Whenever you extract the file name portion of this, which is just this portion, you're going to extract that as a string. Replace every slash with the empty string, and you'll be protected against this attack. And then you can add back in your public image after that. But that's what I expect from this. And an attacker could request any arbitrary file off of your hard drive, including your encryption keys, or if you have passwords.txt, whatever. They're going to just navigate your data structure and try to find a file. And you try to request this, and I get content not found. I am vulnerable to this. My server will take that request and will serve my server.py. But I got content not found. So it's hard to test this one. Yeah.
Can other users request other users' pictures, like profile pictures? Is that allowed?
I don't consider it a security risk for the homework. So if they can, that's okay. And if I look at the request that was actually sent, I got a request for server.py. If I look in my code, I got a request for server.py. Not public image ... server.py. ... is move up one directory, by the way. So I'm expected to get a file in the image directory. I want to go up one directory to public, up another directory to the root of the project, and then get server.py. That's what I'm doing with the ... I'm moving up directory structures. So this is a proof of concept that we can move anywhere in my directory structure and get any arbitrary file. That's what we're doing. But we get server.py. The browser will simplify these. So I typed in these ... but it treated ... as, okay, well, you're going into image and then going out of image. I'm just going to simplify this. You're going into public and then out of public. I'm going to simplify this and just simplify the request to server.py. So it's hard to test this one. So we can use a tool called curl. Actually, I wanted to do this a different way. You can just go into terminal like this. But you do have a terminal right here in your IDE. Whether you're using PyCharm or VS Code, you can just open a terminal window right here and do everything right in place. So just to show you all the tools that we have available to us pretty succinctly, curl, and then the URL. Content not found. Let me look at my server. I got a request for server.py from curl. Curl also simplifies the URL. So to test, curl, oh no, I'm going to forget. I wrote it down to my cheat notes, path as is. There's a path as is flag, and that's going to not simplify the request. It's going to send the request to my server for public image ... server. And now I can see that I'm vulnerable to this attack. I sent my server.py code to this attacker using curl. If you don't want to use curl, you don't want to learn that tool, which is fine if you don't. We already talked about another way to send requests. You can go all the way to the full power of anything you can code. Instead of relying on a tool somebody else wrote, learning how to use the tool, which you really should do. why not just write Python code? Request equals, manually create your request. Don't let anybody else touch your request and simplify it and modify it on you. Send it over our connection, receive the response, and then print the response to the screen. Let's run this code. And we get the same thing. We got our server code by creating a request in Python that requests on localhost 8000, sends this request, gets the response, and prints the response to the screen. Straightforward TCP client code, a lot simpler than the TCP server code you've been writing. And if we go to the server, we can see that request with only one header. We didn't really do much with the request, but importantly, it got that path the way we wanted it to. So there's two ways to check for that vulnerability to try to navigate your directory structure. Okay, buffering images. In LO2 testing, when it says open a new browser tab after a Docker Compose restart, should it be a browser that we haven't logged into previously, so we have to use 3 browsers for LO2 testing? If the testing procedure doesn't specify, then either ways, well, I can't say it that way. I intended for it to be a browser that you're already logged in on. So I just want to make sure that your image is being saved persistently, that you're not using local variables. That should be fairly automatic at this point. You already use databases on homework 2. You're used to using databases. I assume everything's being stored in the database, but still in the testing procedure to make sure that you are actually using the database properly. So it doesn't have to be a new browser where you're not logged in. In fact, I'd rather have it be a browser where you are logged in to make sure that your auth token is also stored in the database and that that's working properly. All right. What do I want to do for saving an image and buffering images? But it says after doing so that the username should be guessed when message is sent. Let me take a look. LO2 testing. Let me make sure I'm in the right spot. Open a new browser tab. Oh, yeah. Yeah, should this be window? I'll think about that offline. Yeah, there's something that I need to update there. And I have to be very careful changing that because anyone who submitted already or finished LO2 already, I got to make sure it doesn't fundamentally change what I'm testing. So I'll carefully modify that to make it make sense. Buffering images. Anybody have a more specific question for this one? Or do I just go over all of buffering images? Buffering images and saving files. What example do I use for that? Oh my goodness, what am I looking for? I thought it was this example. It is this example. So when you're saving your file, like if you're strictly talking about saving the file, this is it right here. Open your, whatever you want to name your file, you're going to use some naming convention. Of course, the homework assignment is all about extracting the bytes of the file from the multi-part request. That's really what you're learning in this course. Saving a file, I'll just give you the code, I don't care. But I've showed this code already in lecture, in fact. But you're going to come up with some naming convention for your files. I've seen a lot of you. I think I put it in the homework doc. I forget if I did or didn't. But if your naming convention is username.jpg, like, not the worst one. The way we're using these images, that they're associated with users, I don't hate it. If you're doing that, make sure that. Oh wait, that doesn't make sense, does it? Maybe it does. Still make sure that you're handling slashes. A TA brought up that what if a user creates a username that contains slashes in it, but then they shouldn't see their profile image at all. It just shouldn't work with that naming convention. So I think y'all would handle that just kind of naturally without thinking about it. But come up with some naming convention. Open a file with the file name for whatever image is uploaded, whatever you want to do. If it's image 1, image 2, image 3, whether it's username.jpg. Open a file with that name. Make sure you open in byte mode. So WB, we're going to write bytes. We're not creating a text file here. It's bytes. And then write all the bytes from the image. Parsed image would be the image that you read and extracted from the multi-part request. That part, that's what the objective is all about. Get those bytes, save them to a file. And then in the database, you would save just the file name, and this is the advantage of having your naming convention be username.jpg, which isn't a good naming convention, by the way. I want to throw that out there. It's fine for the homework. Don't use that naming convention in the real world, because eventually you might want users to have multiple profile images, and they can select which one they want at any given time. You can't use that naming convention anymore. You have to expand it in some way. Maybe you have username 1, username 2, but now you have a user whose username is Jesse, and another user with the username Jesse1, and that breaks that naming convention, and now you're in this huge mess of just a kind of a disaster. Don't use that naming convention in the real world. But for our purposes, I'm not going to stop you. If that's what you're doing to get the job done, do it. But anyway, if that's your naming convention, you don't have much else to store in the database. Maybe a flag to say that they did upload an image, so you know to read that image instead of giving them the default image. But preferably you would store the file name for their profile image in the database associated with that user, along with their hashed password, their auth token, their username. I think that's all we have in the database for them right now, right? Yeah, everything else would be in separate collections or tables. You would save also their file name and not their email address. I'm thinking project part 4, you'll store their email address as well. So if there aren't follow-ups with that, I think that covers it. And then we have 3 minutes, we can get something else in there. What if our user submits a malicious file in a PFP upload? I assume that means PDF. And buffering images, please. Is there yeah, I didn't talk about buffering images. So buffering images is very similar to the WebSocket frames, except you're reading content length. One of the biggest issues I see is, I guess 2 issues that I see most commonly. One, make sure you're not counting the bytes of the headers in your buffering. That's probably the one I mentioned the most because I see that error the most. Make sure you're not reading those bytes. So you're getting the request. Can I get an example up here quick? So you're getting the request, and the headers and that blank line, all of this stuff doesn't count towards your payload length. Your payload length is only the number of bytes after that first blank line character. So make sure those are the only bytes you're counting towards, I said payload length, but content length. Those are the only bytes that count. So this get request has a content length of 0. There's nothing after that blank line. It doesn't have a content length of however many bytes this is. Its content length is 0 because there's nothing in the body of the request. There's nothing after the first new blank line character, blank line sequence. So this has a content length of 0. When you have a content length of that's not 0, you're going to read from the TCP stream. You can assume you got all the headers. You're going to look for the content length header. I didn't even get a post request. You're going to look for the content length header, read that, convert it to an int, get the payload, the content length, and then check how many bytes you've read after that blank line character, and enter a while loop right there. Well, content length, well, the bytes I've read in just the body is less than my content length, then read from the socket again and concatenate those bytes, just like I explained for WebSockets, concatenate those bytes to the end of this buffer. So I'm reading once, I'm taking the headers, parsing those with my header parsing code, getting the content length. Everything after the blank line character, I'm going to put in a separate byte array, and then enter my loop. Well, that byte array's length is less than my content length. Keep reading from the socket and slap in the extra bytes on the end of that. So the 2, I started counting.